Last type of factoring for today is difference of squares, and this should be much faster than the last two lessons you saw. Alright, so again, as a reminder, where is this coming from? If we have a minus b times a plus b, and I distribute, a times a is a squared, a times b is ab, negative b times a is negative ab, and negative b times b is negative b squared. So what ends up happening is those two terms in the middle are the same but opposites, so they cancel. So I'm left with a squared minus b squared, or a difference of squares. Difference, remember, means subtraction. So in order to factor a difference of squares, first of all, determine if it really is a difference of squares. Are each term perfect squares? And they've got to have opposite signs. It doesn't matter which one is negative if you look down at example C, but one's got to be positive, one's got to be negative in order for it to work. So looking at example A, x squared, anytime a variable has an even exponent, it's a perfect square. So x squared is a perfect square, 81 is a perfect square, so figure out what the square roots are and throw them into two parentheses. So the square root of x squared is x. The square root of 81 is 9, 1 positive, 1 negative. In either order, you can multiply in any order, so you can throw the negative on the first binomial and the positive on the second binomial if you want to. And again, to check our answer and make sure it matches where we came from, x times x is x squared, x times negative 9, 9 times x, and 9 times negative 9. Combining like terms, the negative 9x and positive 9x cancel, leaving us with x squared minus 81. Alright, second example. 9 and 25 are both perfect squares, and our variable has an even exponent, so everything is a perfect square. So for these, I always just set up my two binomials. Square root of 9 is 3. Square root of y squared is y. Square root of 25 is 5. 1 positive, 1 negative. And lastly, part C. If you want to make this a difference of squares and flip the order so that it matches the formula, that's fine. You don't have to. But in order to get the negative on the right term, you might want to, and then you don't have to worry about that the first term this time will be 1 positive negative. Alright, so 49 is a perfect square, 16 is a perfect square, even exponents, so I set up my two binomials. Square root of 49 is 7. Square root of y to the fourth is y squared. The way that you square root an exponent is by cutting it in half. So that's why it's got to be an even exponent in order for it to be a perfect square. 1 positive, 1 negative. Square root of 16 is 4. And the square root of x squared is x. So now, as a reminder, 7y squared times 7y squared is 49y to the fourth. We add the exponents when we multiply powers. So for example, if we had a cubed times a cubed, just as a reminder where these exponent rules are coming from, this is a times a times a. This one's a times a times a. So we have a times itself 6 times. So we would add the exponents when we multiply powers. And your U-try problems.